You can build a Minecraft-inspired compass with GPS. Inspired by summer camp adventures, this compass saves and loads waypoints so you always know the way back. The menu lets you pick previous saved locations and points you towards them as you explore outdoors. This feature-packed compass has plenty of settings: light and dark modes for any lighting, a marine mode, and adjustments for magnetic declination and units of measurement. Powered by the Feather RP2350, this project pairs a mini GPS module with a gyroscope and accelerometer. The boards work together to sense the Earth's magnetic fields and gathers your GPS location. Sensor calibration is handled right on the device with a step-by-step walkthrough. Powered by CircuitPython, the code lets you rename the preset waypoints, set your local magnetic declination, and switch between miles and kilometers. You can fine-tune the feel by editing the needle smoothing, the button hold time, or the case fit offsets for your own enclosure. CircuitPython makes it easy to customize and reflash, so you can tweak the compass, drop in new waypoint names, and make it your own without any extra tools. You can get the parts to build your own GPS compass in the Adafruit shop. Links are in the description. You can also download and modify the design files to print your own case. Short headers are soldered to the feather so it fits into the sockets on the TFT feather wing. A printed frame mounts the sensors with machine screws. STEMMA-QT cables daisy chain them together, keeping the connections plug and play. The frame attaches to the back of the TFT display using the PCB screw mounts. A piece of anti-glare film is cut and applied to the TFT display to help with outdoor visibility. The TFT feather wing has a STEMMA-QT port, making it easy to connect the sensor chain to the feather. A battery frame holds the optional LiPo monitor and joins the daisy chain through its own STEMMA-QT port. A tactile push button mounts to the side of the battery frame. A connection splitter is made by soldering a socket header to a jumper cable, sharing the ground connection across the spare socket headers on the TFT feather wing. The slide switch uses a socket-to-pin jumper cable to connect to the sockets on the feather wing. With the pins plugged into the feather wing, the battery frame is fastened over the sensor frame. The whole assembly is aligned inside the main case to the USB port cutout. The slide switch press fits into the lid for easy power on, and it's secured with machine screws. This project was a lot of fun to use with the kids outdoors. It set waypoints around the campsite, and they learned a lot by navigating with a dedicated device of their own. We like to think every explorer deserves a compass that points the way home.